Hello and welcome to UNCC Glass, under the mentorship of Dr. Tao Han, Pedro Regalado Vera, and Professor Bosava. The goal of this project is to create a networked mixed reality system for real-time object detection and localization. The system will utilize the Microsoft HoloLens and a cloud server to perform object detection on any given environment in real time. It will tell the user the name of the object and put a visual marker on the real object in the environment. Mixed reality is an exponentially growing field, and the Microsoft HoloLens is one of the most widely used mixed reality headsets. In our project, we'll be using the HoloLens 1 to project 3D images or holograms into the scene to aid the user.
The system consists of the Microsoft HoloLens, responsible for mapping the environment and labeling objects, and the cloud server, responsible for object detection and parsing image data. They will exchange data via a socket connection. The live video feed from the HoloLens will be sent across the socket, where an image recognition algorithm called YOLO v4 will identify objects and return their names and their 2D coordinates back through the socket. Meanwhile, the HoloLens will create a 3D map of the environment, raycast through a projection to the environment mesh using the provided coordinates, and to create a correctly placed marker in the scene. The specifications for our system are to have an object recognition algorithm capable of detecting multiple objects, have a localization and mapping algorithm that locates and maps both the user and environment, have an easy-to-use user interface for the object detection, have a control algorithm capable of altering speed and quality, and have a system capable of detecting objects and labeling them within 3D space.
Communication and networking consists of a client socket and a server socket to send data between our HoloLens and server. It will receive an image stream at the server and return processed data including the object name, location, and identification accuracy. Capture and rendering captures PV images and spatial data through a socket to send to a server for processing and display received data in the environment through a heads-up display on the HoloLens. The design uses a user interface to toggle object detection. Once the processed information comes back from the server, the HoloLens will create correctly localized object marker in the scene.
Data processing design consists of the socket server, our object detection algorithm YOLO v4, and OpenCV as well. OpenCV is used for the parsing of the image to identify the center of the object in the 2D image. The coordinates of the center will be found as pixel values, which will then be projected proportionally to raycast to the location in the 3D scene on the HoloLens. Alright, so the detailed design of our project has been finalized, and the team was able to get object detection running in real time through the HoloLens with an average FPS of 29.8.
Plans for next semester are to move from 2D object detection bounding boxes to 3D markers using spatial mapping and including percent accuracy. We also want to create a user interface that puts the performance of the HoloLens experience in the user's hand.